first talk of today, we have resilient communication in modern crisis, and it will be given by Toni Lindén. He is a co-founder and CEO of KNL, and with that, I would like to pass the floor to Toni. Here the slide changes.
Yeah. Thank you, and very happy to be here. So I have a brief presentation about resilient communication in modern crisis, a bit kind of a benchmarking against lessons learned from Ukraine, and leading that to 6G and the next generation of communication. So currently we look like a hyper-connected. We have, if you look at your cell phones, you have a full bar, full internet access whatsoever. But are we really resilient in a real crisis? And actually this hyper-connected situation we are living currently, that creates an illusion of resilience. And we should not be naive on what works under attack. This is a picture from Ukraine. This illustrates the environment where our networks must survive. It's a very hostile environment in spectrum. You have a constantly contested and congested spectrum with the EW and cyber percent. Also traditionally, we've been thinking the battlefield as a kind of a strict line. You have units fighting, and then you have other units, let's say, more distant from the front line. But only recently in Ukraine we have started kind of talks about kill zone and things like that. The first couple of years, especially in Ukraine, it was actually pretty, let's say, mixed up environment. People going to work, kids going to school, and units fighting across the corner. So this is the environment we should think when we plan our next generation connectivity, and think that our networks, they should still serve us when we have the worst weeks of our lives. As we heard, Finland and Sweden are pretty well prepared compared to many other countries when we talk about the resilience and infrastructure. In most cases, what we see today is legacy land mobile radios and ad hoc use of commercial 4G, 5G. Those systems are not designed for the modern battlefield. They work beautifully on a good day, but that's the illusion we are creating. So when we stretch the peacetime networks and then we assume that they would behave like wartime networks, I think we are a bit fooling ourselves. So aging, still quite often analog-based radios, they underperform in congested electronic warfare heavy environment. When we use commercial cellular, those systems need hardening, or they put their users under threat. And if we rely too much on the commercial infrastructure and integrate commercial devices and applications to the operation critical systems, we actually increase a new threat vector with the malware, cyber that are present on the industrial environment and wild internet. We also rely quite a lot on space, like we just heard in a couple of previous presentations. But that actually leads us to the situation where space is also becoming a battlefield. As you can see from the recent news, Russia and China are actually building capabilities to effectively fight on space and effect on the satellite constellations. When relying on commercial operators, we can rent bandwidth, but we can't rent resilience. If we use Starlink as a great example, no questions asked, Starlink has had a very important role in Ukraine. But Starlink's position in Ukraine has also raised a lot of questions. Who actually owns our resilience? And what is the cost of resilience? To put this in a context, SpaceX has raised funding of close to $12 billion US. That equals roughly the total combined number of investments in Finnish telco infrastructure for the past 20 years. And just rewinding back to 20 years, that was actually the time when the 3G rollout started in Finland. So take all the investment from that time till nowadays, and you get the rough idea, the magnitude of the investments that sovereign satellite capability might require. Also, we have a lot of data from Ukraine. And we need to be quite cautious that we don't jump into the conclusion. So it's very easy to think that Starlink has a dominant role in Ukraine. The use of cellular networks is large scale in Ukraine, and then think that that is actually how we should consider our modern crisis ICT environment. But we need to understand the underlying layers there. So for example, the use of Starlink and a commercial cellular in Ukraine, it's not because of a superior product market fit. It's because that's the only thing what they have available. So we need to actually understand that what is the operating environment and what are the requirements for future systems in order to have the requirements and understanding of the environment right. Spectrum has become a fifth dimension in the battlefield. That's present all the time, and there's even saying that who controls the spectrum controls the entire battlefield. The networks are becoming more and more hybrid, because if you think about the real resilience is not a system that you build to survive in every case. There's no such a system. The real resilience lies in having multiple systems where 90% can fail and you still maintain operational. That's the true resilience. And when we talk about the importance of data, I think that's that you can take as a given that the battlefield is becoming more and more data-driven. Systems will be autonomous. Information is the key to win the battle. And we have another layer we touched on the previous panel, for example, the power resilience. I think that's quite often overlooked by tech people. We take it as a granted. But let's say that your SATCOM is jammed and you have a massive power outage for just 72 hours. What would happen? And we also need to have the governance, different agreements, policies in place to be efficient. So understanding the environment, it's crucial when we think about the next generation communication and how we should build the infrastructure for the upcoming crisis. Digitalization of the battlefield has been ongoing for the past decades, and there is clearly an operational need that is driving the development. War in Ukraine has not started this. but war in Ukraine has accelerated this change and make it visible to different stakeholders. I think Finland and Sweden has quite different approach compared to many other countries when building a sovereignty. In our operational scenarios, we don't take cellular networks as granted. Like we heard, we quite often struggle with the poor satellite coverage, so we needed to design it a little bit differently. We are not perfect in Finland, but personally I think that we have done a lot of things right. So I will use KNL here as an example, not to sell you radios, but to explain that what I'm talking here, it's not the roadmap item or Vision 2050, that is reality today. So what we have done in KNL is that we took the very old-fashioned HF radio. No one's been interested for the decades. It was labeled as a doomsday radio because kind of that was the only practical solution for HF. When everything else is gone, you can send the final message. But what we have actually done is that on KNL we have reinvented the whole protocol stack on top of physics, and suddenly we have brought this forgotten part of the spectrum to the modern era, where we can pretty much match with the performance with the SATCOM. Most use cases available on SATCOM, you can actually now do also over the HF. We have put a lot of effort on how to understand the spectrum and how to dominate the spectrum. And if you think about the HF part of the spectrum, that's probably the challenging part you can imagine, with the interference, other users transmitting thousands of kilometers. It's a totally chaotic environment. And for example, those learnings we have done to make modern HF system to work, that could be utilized on the cellular, higher frequency band radios, etc. in the future. So we have a lot of building blocks. By any means, I don't mean that the HF will replace other tactical networks, satellite, or 5G, but it gives a sovereign backbone when the other systems are not there. And this is all about 6G. So in normal talks, when we talk about 6G, we focus on cellular. But the fundamental idea of 6G was that it's the network of the networks. So 6G is not only cellular, it is the hybrid approach of a future networks that must be secure, autonomous, and self-healing. Those capabilities cannot be add-ons later on. It needs to be the starting point. The first requirements, how you start building those systems. And you need to combine terrestrial, non-terrestrial, and tactical networks to create a true sovereignty. Like I said, you can't build a single system that will survive always, but you can have multiple systems and consider it like an onion, that you can take off layers and you still have something that will keep you operational even when 90% is gone. And resilience, it cannot be built in isolation, so it requires partnership among governments, operators, industry, and academia. So, just summarizing my talks here, I think the illusion of resilience comes from the peacetime network, while the real resilience lies in hybrid sovereign systems that are designed for loss. We already have a lot of working building blocks and technologies. We just need to build them into the requirements and take those as design principles. And if we design from real crises and we have the requirements right, only then we can give our people what they thought they would have all along. Communication that are there when everything else is not. Thank you.
Yes, thank you very much. Heidi Himmanen from Traficom. Yeah, I think your innovation is really cool. When I started in the regulator 16 years ago, HF was ancient, and now you've done something with that. I have two questions. The first one, do you have references to like civil applications for your communication systems? And then the other question, you say that this is 6G, so are you planning on putting your technology into the 6G evaluation process of ITUR to get the 6G stamp for it? Thank you.
Thank you, very good questions. If starting with the easier one, we do have industrial applications as well. So we provide connectivity, for example, to the merchant vessels, where the focus is on real-time IoT data, and again that works in parallel with the SATCOM. We also have some other industrial applications on the energy sector, where basically this critical communication has a very important role for business continuity. So it's not just the military application. There's a wide range of use cases across the different stakeholders, both governmental and industrial. And the second question, we are still kind of on the scale-up phase, so we've been too busy for delivering the radios to the market to contribute on 6G standardization. But I will take a note on that because definitely that's interesting for us.
Thank you. I was a little bit unattentive in the beginning. What data rates do you get, and do you cover the oceans?
Yes, so we do have a full global coverage with the system. So through the HF radio, you can normally have point-to-point distance from some tens of kilometers to thousands of kilometers, including also the Arctic regions and sea areas. On the data rate-wise, we are on the kind of a low end, so currently roughly 300 kilobits per second. But one advantage of our solution is that since we have the full stack in our own hands, we can optimize the user experience so that, let's say, for example, the chat capability, when we integrated NATO JChat, by using a smart AI-driven compression, you actually get the 3x user experience compared to legacy systems. So from the application perspective, we have installations where we support a large countrywide governmental critical infrastructure. The only services we don't support is a two-way video conferencing, but situational awareness, messaging, voice, target acquisition, all that runs over HF, including a native IP that creates a capability to offer IP crypto over HF.
Yeah, so you answered my question partially that you have this IPsec capability, but do you have, let's say we've been talking about this post-quantum cryptography and all of these things, and then you're talking about HF. That means if you're talking about the adversary, they can most probably hear you out. So what's your take on like intercept capabilities towards the adversary? So do you, what are you doing to make it more difficult, the life more difficult, not impossible, but difficult for the adversary?
Yep. Very good question. I think there's a couple of kind of directions we address this topic. First of all, we have a system crypto that is a standard AES-256. So each and every bit and byte over the radio channel is always encrypted. But then on top of that, the end customer can have their own IP crypto that can basically take it to the NATO cosmic top secret. So kind of that's the kind of the crypto part. But then probably even more important is the dominance in the spectrum. So when you we don't use the fixed frequencies. It's a pure cognitive radio solution where we basically receive the whole spectrum all the time. We see exactly everything what's happening in the spectrum, and the system adapts the whole network every second throughout the whole frequency range. And if you think it from the, let's say, electronic warfare intelligence perspective, you see some very short, we talk some milliseconds to some seconds events on random part of the spectrum at the random time, because we don't need to have a network synchronization that never occurs again at the same way. So it makes very hard to kind of dig those signals from congested HF spectrum, where you have all kind of interference and a lot of signals radiating across the globe.
Thank you, Toni.
Thanks.
Thank you, Toni, once more.